ঠিক আছে সো colloids বিষয়ে আমি যেতিয়া পঢ়িম আমাৰ অকমান ব্যাকওয়ার্ড যাব লাগিব and we have to know what is this solutions already আমি solution chapter to পঢ়িছো solute in solvent is known as solution correct so solution তিন ধৰণৰ থাকে one is the true solution one is the colloidal solution and the other is the suspension ठीक है one is the true solution again showing you one is the true solution one is the colloidal solution and one is the suspension ठीक है solution तीन धৰণৰ true solution colloidal solution and suspension okay let us go to the colloidal solution first colloidal solution are best example hol gakhir milk okay so in colloidal solution there is two things in solution already we have discussed that there is two things in solution one is the solute and the other is the solvent ठीक है এতিয়া আমাৰ solute particle to this is our solute okay our solute particle can vary in its sizes right solute particle or kiba eta size hobo pare kom hobo pare beshi hobo pare so like that the size of if the solute particle size if the size of the solute particle is between 1 to 1000 nanometer if the size of the colloidal like solute present in the colloidal solution is 1 to 1000 nanometer then it is known as colloidal solution ठीक है solution মানে কি solute আৰু solvent solute or size particle size যদি 1 ৰ পৰা 1000 nanometer ভিতৰত হেতু colloidal solution বুলি কয় if the size of the solute particle is greater than 1000 nanometer greater than 1000 nanometer it is known as suspension greater than 1000 nanometer it is known as suspension for example sand in water okay sand in water is an example of suspension colloidal solution or example whole milk one of the examples okay so there are many examples of colloids but one of the example is definitely milk ठीक है true solution example to key true solution is salt water or sea water there is salt in water okay salty water so that is a true solution ইয়াতে যোনটো solute থাকে solute particular size less than 1 nanometer fine less than 1 nanometer okay now colloidal solution is heterogeneous heterogeneous মানে তুমি যদি মাইক্রোস্কোপৰ তলত তুমি গাখীৰটো চোৱা like if you see the milk under microscope you will see there is two things one is the white see you will see something like this there is the water part and in water this white fats are floating okay this white color fats are floating this you will see under microscope tar mane milk has two things one is this thing that is the white part which is the liquid water liquid and one is the white fats which is floating on the water okay session the fats is known as session or the protein is known so this are there this fats is flowing in water so this is our milk fine so clearly তুমি দুটা বস্তু দেখা পাই আছা এটা হল water এটা হল fats because এটাৰ চেয়ে বেছি বস্তু দেখা পাইছা হেতু তাৰ কাৰণে heterogeneous বুলি কোৱা হয় heterogeneous means it is you can see more than one thing similarly in suspension also sand water so দুটা বস্তু দেখা পাবা sand water so it is also a heterogeneous okay heterogeneous fine heterogeneous in case of true solution তুমি যদি এটা মাইক্রোস্কোপত চোৱা একো দুটা বস্তু দেখা নোপোৱা like salt water even under microscope also you will see like water only you will not see two things so that's why this solution is a homogeneous solution ठीक है So size to diya hoise greater than 1000 nanometer. It is greater. Oh, this is not greater. It is between 1 to 1000 nanometer. Between 1 to 1000 nanometer. Fine. Between 1 to 1000 nanometer. Okay. আচ্ছা মিল্কৰ দুটা বস্তু আছে পানী আছে আৰু এই ফেটছ বিলাক যোনবিলাক পানীৰ ওপৰত ফ্লোট কৰি আছে বা পানীৰ ভিতৰত আছে so there are two things so if there is two things that means it's a mixture হলে এটো পিউৰিফাই কৰিব পাৰে না নাই one of the method of purification that means if I can take the water out and take the fats out of milk okay so the best so the answer is ordinary filtration is not possible simply তুমি milk যদি filtered ভৰাই দিয়া তুমি তাৰ পানী আৰু fats টো separate কৰিব নোৱাৰা so ordinary filtration is not possible if I have written ordinary that means special filtration is possible okay ordinary মানে normal filtration that is not possible to separate the fats and the water okay so in that case what is possible is there is something a very fine kind of a filtration is there which is known as ultrafiltration eto because particles bilakor size kiman 1 to 1000 nanometer so eto rakhab নোৱাৰে মানে ordinary filtration ইমান সৰু বস্তুটোৰ size eto rakhab নোৱাৰে fine so in case of ultrafiltration it is ultra means a very small quantity okay so in ultrafiltration what happens in ultrafiltration what happens a fats particles like rokhai dibo pare like separate kori lobo pare from the water and the fats particles will be separated this is a very advanced form of filtration ultrafiltration boli koa hoy ঠিক আছে next point to ki settle on centrifugation তোমালোকে এটো বস্তু normally film ত দেখা পাইছা বা ঘৰতো দেখা পাইছা চাগে hey গাখীৰটো লৈ কেনে if you take the milk okay and then suppose you are taking the milk in a container you're taking the milk in a container and in the milk you are putting a centrifuger means something like this now this action has to go on once this side the other time this side okay so eto ghurai what you will get you will see that all the fats has accumulated on the top the liquid part is on the bottom okay this is the process of centrifugation মাখন যেনেকে বনায় okay so this is the way মাখন মানে কি all the fats গোটেই মিল্কৰ fats কেটা concentrated কৰি দিয়া হেতুৱে মাখন right so how you make butter out of milk that is the simple technique okay condensation কৰে হেতু centrifugation process বুলি কয় centrifugation because there is a centrifugation force which is applied okay there are two types of force you already know what is the centrifugal force and one is the centripetal force if the force is acting towards the center it is centrifugal force okay so the fats the solute particles that is the fats which is floating on the water this fats actually settle on centrifugation fine settle মানে তলত পৰি যায় বা ওপৰত আহি যায় okay these fats particle are not visible under naked eyes you cannot see them directly but you can see them under microscope okay you can see them under microscope very important cannot be visible under normal conditions but can be observed under microscope dile etu dekha paba okay so centrifugation korile ki hoy ultimately centrifugation to korile it becomes settled the fats can be separated from the water part okay fine all right next is phase of colloids colloids মানে কি colloids হল এটা ধৰণৰ solution this is a solution don't get confused by the word colloid this is nothing but a solution whose solute particles is between 1 to 1000 nanometer 1 to 1000 nanometer okay whose solution in the solute particles is between 1 to 1000 nanometer. If it is like that, then it is known as colloids. এটা তোমালোকে জানা যে সলিউশন দুটা পার্ট থাকে, এটা হল সলিউট আর এটা হল সলভেন্ট। ঠিক আছে, সলিউশনৰ কি থাকে, এটা হল সলিউট, solution has two parts, solution has two parts, and that is the solute plus solvent, correct? Solute plus solvent মিলি পেলাই solution বনায়। Similarly, because colloid to এটা ধৰণৰ solution হয়, এটোকো কিবা মানে like there should be two parts, definitely there is, it is the solute and the solvent। ठीक है, colloids have two parts, that is the solute and the solvent, and when you see them, they are not known as solute in case of colloids, they are known as dispersed phase। নামটো কি, dispersed phase, এটু একো নহয় but solute only, solute is known as dispersed phase, and solvent in case of colloids is known as dispersion medium। ठीक है, solute is known as the dispersed phase and solvent is known as the dispersed medium or dispersion medium also they can tell। Okay, it might also be known as dispersion medium। Fine, so colloids or দুটা ভাগ আছে, এটা হল dispersed phase and আন এটা হল dispersed medium। Clear? If there is anything that has confused you till now, you can tell। Similar, just we are making an analogy between the solution and colloids। Colloids is a special type of solution whose solute particle is between 1 to 1000 nanometer। Fine, it has dispersed phase, dispersion medium। Dispersed phase is nothing but the solute, dispersion phase is nothing but the solvent। Let us revise what you have learned till now। Solution or দুটা বস্তু থাকে, solute and solvent। If the solute particle is between 1 to 1000, it is colloidal। If it is below 1 nanometer, it is true solution, and if it is above 1000 nanometer, it is suspension। Example sand water, example milk, example salt water। Fine, colloidal solution is heterogeneous between 1 to 1000 nanometer। Ordinary filtration is not possible to separate out the fats and the water। Ultrafiltration is a special advanced technique of filtration which is possible। It settles on centrifugation। মাখন to যেনেকে বনায়, centrifugation process, you take the thing and just roll it, roll করলে কি হয়, this is creating a centrifugal force in the center of the tub of milk or vessel of milk। Okay, অকলে milk নহয়, হ্যাঁ, milk I have just taken as an example, you will see much details। Solute visible under microscope, so you can see the fats particles only under microscope। তার কারণে দুটা কম্পোনেন্ট থাকে ন, ওয়াটার থাকে আৰু ফ্যাটস থাকে, তো হেতুৰ কাৰণে এটো হেটেৰোজেনিয়াস বুলি কয়। ঠিক আছে, so solutionৰ নিচিনা colloidsৰ দুটা পাৰ্ট থাকে, that is the solute and the solvent, that is the dispersed phase and the dispersion medium। দুটাৰ মাজত তফাৎ কি, what is the difference? The difference is quantity, it has lower quantity। Solute is lower quantity, that is the dispersed phase is present in the less quantity, and dispersion medium is present in higher quantity। Fine, okay, so আমি এটো বস্তু আগতেও দেখিছো in case of solution chapter। Dispersed phase, as I said, it is representing nothing but the solute, and dispersion phase is nothing but it is our solvent। ठीक है, যদি dispersed phase or the solute is solid and dispersion medium is solid, both are solid only, this is in greater quantity, this is in lower quantity, quantity difference। ঠিক আছে, আমার এটো হল কম কোয়ান্টিটি, সলিড টু হল কম কোয়ান্টিটি, আৰু এটো সলভেন্ট টু হল আমার বেশি কোয়ান্টিটি। ঠিক আছে, সো দিস ইজ দ্য ডিফারেন্স অনলি। এটোৰ এক্সাম্পল টু কি হয়, দুটা যদি সলিড হয়, এটোৰ এক্সাম্পল টু কি হ'ব, এটোৰ এক্সাম্পল হ'ব, এটোৰ কোৱা হয় সলিড সল বুলি কোৱা হয়। কলয়েডছৰ ক্ষেত্ৰত সল ওয়ার্ড टू ব্যবহার করা হয়, लाइक यू यूज द वर्ड सॉल, SOL। ठीक है, इसको यूज करते हैं, तो सॉलिड सॉल बोला जाता है, सॉलिड सॉल। फाइन, एग्जाम्पल इज जेमस्टोन। रिंग पिंधे जे মানুহে, ring pindha to etu eta colloid hoy. Ring pindha a moonstone, then what was the name, topaz, all these stones are there, na? Pokhraj, then Prabal, Rakta Prabal, and then there's so many other different moonstone is there. So all these different types of panna is there. So all these different types of stones are nothing but they are colloids. Okay, they are colloids. So they are known as solid sol. কি বলে কোয়া হয়? Solid sol. They are known as solid sol. Fine. Remind you, both the solute and the solvent are solid. Solute means dispersed phase and solvent means dispersion medium. Second, okay, if the dispersed phase is solid and the dispersion medium is a liquid. ठीक है, dispersed phase to solid hole আৰু dispersion medium to liquid hole এনেকা যদি হয় by chance, ঠিক है, then they are known as simply sol. এটো simply sol বুলি কোৱা হয়. Okay, এটো sol বুলি কোৱা হয়. Dispersed phase is solid and dispersion medium is liquid. এটো sol বুলি কোৱা হয়. Okay, this is known as sol. Fine. Example to কি আকৌ দেখাই আছো. Dispersed phase is solid, dispersion medium is liquid. দুটা মিক্স কৰিলে কি হ'ব? এটো basic quantity, এটো কম quantity. This is lower quantity, this is higher quantity. My right side, all these are higher quantity, all these are lower quantity. So solid, lower quantity of solid mixed in higher quantity of liquid, provided that this solid is the size is between 1 to 1000 nanometer. This is the size range of these things. This is the size range. When this is mixed in liquid, liquid or কোনো dimension or কথা নাই. When they two are mixed, they are known as sol, simply sol. Fine. Example whole paint. Paint is a good example. Wrong. Okay. Paint is a good example. Paint is nothing but in the liquid, the solid particles are floating. The solid particle size is between 1 to 1000. That's all. Fine. Next, আমি এবার কি করিলো, we take the solute as solid, dispersed phase as the solid, and the dispersion medium as gas. ठीक है, hawa, gas. So when we take solid and gas, then it is known as aerosol. Sol word to থাকিব প্রায়, because it is in air, it is known as aerosol. কেতিয়াবা যেনেকে পুলিচে টিয়াৰ গ্যাস পেলাই দিয়ে হাৱাত, okay, or laughing gas. These are some gaseous particles or solid particles. Sometimes they float in air. So that is one example of aerosol. Aerosol means something that is where the dispersion medium is air. If the dispersion medium is air, okay, then it is known as aerosol. মনে রাখিবা, মানে solvent to যদি হাওয়া থাকে air, then it is known as aerosol. Example is that of a smoke. Smoke is nothing but solid particles in air. Fine. Hopefully you are understanding what I'm saying. So please ask questions if you're having any confusion. Next, solid, liquid, solid আমি চালো. এতিয়া আমি লিকুইডৰ কাৰণে চাওঁ. Okay, in case of liquid, what we'll see, in case of liquid, the first thing, when a liquid is mixed with gas, a liquid or আকৌ dimension to imane থাকিব 1 to 1000 nanometer. When the solute is liquid, that is the dispersed phase is a liquid, but dispersion medium is a solid. Eta ki hoy, the example is that of a gel. Okay, jelly. Example is jelly. So we all have taken this jam, fruit jam and all these things, right? Or even hair gels, whatever you can think about, shaving creams and all. So they are liquid. There is small quantity of liquid in large quantity of solid. So that makes a gel. Okay? That makes a gel. And the example is simply a jelly. Okay? Done. Next. when the dispersed phase is a liquid and the dispersion medium is also a liquid, liquid in liquid. Okay, liquid in liquid. The best example is paint. Okay, liquid in liquid thake. So when liquid and liquid mixes together, they are known as emulsions. Emulsion boli koy. Best example is oil and water. Oil and water. Okay, example yate milk diya hoise, but it can be also oil in water. Oil in water. It can be oil in water. Okay, fine. Oil in water. So emulsion is a mixture of liquid and liquid. Water hole eta liquid. Etor dimensions সৰুৱে হয়. Oil may have, the oil particle may have size between 1 to 1000 nanometer. Fine. Next is gas in gas. Okay, gas in gas. Gas in gas. Okay, if we have gas in gas, then also it is known as aerosol. Jetia tomar medium to gas thakibo, mane dispersion medium, that is the solvent medium, that is a gas. In that case, it is always known as aerosol. ठीक है, एटो aerosol बुलिए कोआ है. ठीक है. Aerosol or example की हो पड़े. The example of aerosol is fog, mist. Okay, fog, mist, all these things. Dew. Okay, coolly, that is the fog. Okay, next. Fine. When we have gas in solid. Okay, this is solid by the way. Gas in solid, gas to loa hoise in solid, then it is known as solid sol. Again solid sol. Gas in solid is known as solid sol. Solid sol ako eta jagat paisila tumaloke. That was solid in solid. Okay, solid in solid was also known as solid sol, and here gas in solid is also known as solid sol. The name solid sol repeats itself 2 times. Example is, because yate gas ase, so you can take the example of pumic stone. These stones are used for scrubbing. Okay, scrubbing of legs and all this are for hard surface. Pumic stones are generally used. You can see a pumic stones. It is very light because of air present in it. Very, very light. It may float in water also. Okay, so this is pumic stone. Fine. Then the next is gas in liquid. Gas in liquid. So what is a gas in liquid? Gas in liquid. So what is a gas in liquid? It is foam. Liquid to basic thake, kintu liquid or bhitor ki thake maximum gas thake. Gas in liquid, when it is a combination, mostly carbon dioxide thake. When gas in liquid, তুমি যেতিয়া পেপসিৰ এটা বটল খুলি দিয়া বা হেৰি যিকোনো কোল্ড ড্ৰিংকছৰ এটা বটল খুলি দিয়া, তেতিয়া নৰ্মেলি কি হয়, বহুত ফোম ওলাই আহে, right? Lot of foam comes out, lot of like we have common experience. Now this foam is nothing but our carbon dioxide when it was mixed in water. So when you take gas in liquid, then it results into foam. So one of the example is carbon dioxide. Carbonated water also is one example, but here it is taken as soap leather. Sabun to loy ghoi thakile ki hobo, bahut phen ulai hai, right? So that is our soap leather boli koy, LATHER. Fine. So I'll show you all together once. Okay, fine. So we have learned a thing or two about colloids. Next, এতিয়া স্পেশাল কেস। স্পেশাল কেসটো কি, যদি ডিসপারশন মিডিয়াম, এইখিনি আসলে ডিসপারশন মিডিয়াম, ঠিক আছে, ডিসপারশন মিডিয়াম, যদি এই ডিসপারশন মিডিয়ামটো ডাইরেক্টলি ওয়াটার বুলি কৈ দিয়ে কোনোবাই, ইট ইজ ডাইরেক্টলি, ইফ দে সে ইট ইজ ওয়াটার, দেন ইউ মে নেম ইট হাইড্রোজল। ডাইরেক্টলি যদি ওয়াটার বুলি কয়, ইউ মে নেম ইট হাইড্রোজল। ठीक है, you may name it hydrozole. So water, if you take directly, if you take water directly, you can name it hydrozole. Fine. Next, if dispersion medium is alcohol, মানে dispersed phase যে কোনো বস্তু থাকুক, এটা আমার solvent to হয়। This is our solvent only. It is known as dispersion medium in case of colloids. If it is alcohol, it is known as alcohol. Alcohol. And if it is benzene, it is known as benzozole. Okay. And if it is air, it is known as aerosol. Fine. It is known as aerosol. Fine. This is what it is. Water থাকিলে hydrozol বুলি কয়, alcohol থাকিলে alcohol বুলি কয়, ALCOSOL, ALCOSOL, alcohol বুলি কয়। Benzene থাকিলে benzosol বুলি কয়, air থাকিলে aerosol বুলি কয়। This is directly depending on the name of the dispersion medium. ঠিক আছে। So বহুত কেইটা বস্তু শিকিলো আমি, সলিউট আৰু সলভেন্টৰ নিচিনা ইয়াতে ডিসপার্সড ফেজ আৰু ডিসপারশন মিডিয়াম থাকে, নামটো লৈ কনফিউজ নহবা। ফেজ মানে সলিউট, মিডিয়াম মানে সলভেন্ট, ডিসপার্সড ফেজ আৰু ডিসপারশন মিডিয়াম, ঠিক আছে। সো বেলেগ বেলেগ কম্বিনেশনৰ বেলেগ বেলেগ নাম থাকে। Let us move on to some specific salts, colloids. Okay, so there are some specific colloids that we'll talk about. They are known as the lyophilic, ly, lyophilic and lyophobic, so colloids. Okay, they are known as the lyophilic or lyophobic colloids. Lyophobic. Philic, philic means loving. Okay, and phobic, phobic means hate, dangers. Phobic does not mean that they like each other. ठीक है, তোমালোকে এইটোৰ comparison ক'ত কৰিব পাৰা জানা? From solutions, if you remember anything, lyophobic is positive deviation from Raoult's law. Positive deviation, মানে those liquids, those solutions which has positive deviations from Raoult's law. Positive deviation. এটা লগত directly এইটো লিখাটো ঠিক নহয় because it is completely taken in a different sense, but if you compare it, it is something like positive. Positive what কি হয়? Solute and solvent particles do not like each other. They do not like each other, right? Phobic মানে কি? ভয় খাইছে। So from this word, it is more clear. মানে colloid or solute particles or solvent particles, they don't like each other. Lyophobic means the dispersed phase and the dispersion medium, they hate each other. And here the dispersed phase and the dispersion medium, dispersion phase, see, dispersed phase and dispersion medium, they love each other. Okay, and phobic means dispersed phase and dispersion medium, they hate each other. Okay, done. So this is phobic and this is philic. Basically একেটাই বস্তু, এটো পজিটিভ ডেভিয়েশন, এটো হল নেগেটিভ ডেভিয়েশন। নেগেটিভ আৰু পজিটিভটো যদি মনত নাই বাদ দিয়া, just remember dispersed phase and dispersion medium, they like each other. Dispersed phase and dispersion medium, they do not like. That's all. Next, properties. What are the properties? Ease of preparation. ease of preparation মানে lyophobic আৰু lyophilic sol, what is the ease of preparation of such kind of sols or such kind of colloids? ठीक है, colloids can be often referred as sol. Colloids of মই কেতিয়াবা sol বুলি ক'ব পাৰো. It means colloids only. It is often referred as sol. Okay. Ease of preparation. Ease of preparation মানে কিমান সোনকালে বনাব পাৰি, because they are philic, they are loving, no, they can be formed easily formed by directly খালি mix কৰি দিলে হ'ল। ইহঁতে ভাল পায় থাকিব লাগে, like they want to stay together, so what is the problem? They will directly mix, no issues. You will not face any problem when you mix the dispersed phase and the dispersion medium. Dispersed, oh sorry, this is philic, this is philic. Philic means dispersed phase, dispersion medium, right? So they are these two likes each other, so they directly mix without any problem. You do not need any separate thing to mix them. Okay. Whereas in case of lyophobic, it is not the same case. Lyophobic, the dispersed phase do not like the dispersion medium, and this requires special method for mixing, because normally ইহঁতে mix হ'ব নিবিচাৰে because phobic হয়, anti হয়। ठीक है, next, ease of preparation. So lyophilic is easier and lyophobic is harder, that's all. Particle nature, particle माने solute particle nature, solute particle nature, ठीक है, solute particle nature. So what are this? They are true molecules. Solute particle whole, they are true molecules. What is the meaning of true molecules? True molecules माने suppose in water, suppose in I have taken a vessel. Inside the vessel there is water, okay, and in this water there is, the particles are single particles, so they are single particles, so they are like these particles are the colloids particles directly alone they are one molecule, and they are directly, their sizes directly fall in the range of that of colloids. So they are true molecules, they are original molecules who can be known as colloids pure, ठीक है, because directly ইহঁতৰ যদি সাইজটো তুমি ডিটাৰমাইন কৰিবলৈ যোৱা, ইহঁতৰ সাইজটো কিমান ওলাব, পাৰ্টিকুলাৰ সাইজটো কিমান ওলাব, 1 ৰ পৰা 1000 নেনোমিটাৰৰ ভিতৰত ওলাব, ঠিক है, original solid particle size. But in case of lyophobic colloids, in case of lyophobic colloids, aggregate of many molecules. What is the meaning of aggregate of many molecules? তাৰ মানে এই ইয়াতে যোনটো solute particle হয়, হি অকলে colloidsৰ rangeত নাহে. Suppose there is this liquid is there, this liquid is there, suppose there is a liquid over here, there is a liquid over here, ठीक है. So in this liquid there are colloids, there are particles, okay. Suppose ইয়াতে দুটা particle দিলো মই, each particle has lesser size than the range of colloids, ठीक है. Suppose this particle has how much? This particle has 0.5 nanometer, ठीक है. So it has 0.5 nanometer. Eta particle size kiman 0.5 nanometer. Fine. Eta particle size kiman 0.5 nanometer. A2 size of 0.5 nanometer. It also has 0.5 nanometer. I have taken this vessel, and in that vessel I have taken a liquid, and in that liquid I have taken two particles. Each particle size is 0.5 nanometers. তোমালোকে জানা যে এটো colloid নহয় individually it is like that of a true solution. It is not a colloid, it does not fall in the range of the colloid, then if these two particles somehow combine, korile kiba karone, then their size, now both were 0.5, 0.5, they will combine to form 1 nanometer, right? They will combine to form 1 nanometer. They will combine to form 1 nanometer. Since they are combining to form 1 nanometer, they fall in the category of colloids now. So this is known as aggregation. Aggregation মানে গাঠজোড়। কেতিয়াবা এনেকুৱা হয় ন, like there is, suppose two parties are fighting for the election. There is two parties who are fighting for the election, or maybe say three parties, A, B, C. We are fighting the elections. Okay. So suppose to form the government, you need 60% seats. Out of 100 seats, you need 60 seats. Okay. So this party got 40 seats. This party got 40 seats. This party got 20 seats, and this party got 40 seats. Okay. So tinta party fight kori ase for the election of a certain state, and they want to win the contest. They want to become the ruling party. But party A has got 40 votes, 40 seats. Party B has got 40 seats. Party C has got 20 seats. So in that condition, what one party can do is, suppose A says that A and C will combine together. A and C will combine together. ठीक है? A and C যদি combine কৰি লয়, ইহঁতৰ seats কিমান হৈ যায়? Ultimately মিলাই পেলাই 60. So they are eligible to form the government. So they are eligible. So they are eligible to form the government. Now they are not original winners, right? A and C, they are not original winners. But when they combine, they have made the qualification as a ruling party. Okay? How? By combining, they have become the ruling party. So similarly, yate particles bilak ki hoy, etu ki koy, etu koy aggregation. Etu je gathjor hol, this is known as aggregation. Okay? Similarly, yateo lyophobic particles or junto tomar solid particles thake, ihote originally colloid or category nahi. Ihote combination kori pelai, they are like 2-3 particles or more than that particles, they combine so that their size comes in the range of colloids. So they are lyophobic. Fine. Next, visibility. So not easily visible. Visible. Okay. Because horu thake yote, though they are like 1 to 1000 nanometer, not easily visible even under ultra microscope. Easily visible means it is very difficult to view them. It is not very easy to view them. It is very difficult to view them. Not easily visible even under ultra microscope. Why? Because they are on the lower end. See, jikono bostu thake eto range ase na 1000 nanometer. So if it is towards 1000 nanometer, it might become visible. But if it is suppose 2 nanometer, it is still a colloid. Jodi dhora eta particle lolu moi, that is only 2 nanometer, it is still a colloid, but it is on the lower end, cheaper end. Okay, so it is in the lower end, so it is not directly visible. Fine. Visible hobole okkoman size to dangor hobo lagibo. Done. Particles are easily detected under ultra microscope. Particles are easily detected because they are on the higher end. Okay, they are on the higher end. They are towards 1000 nanometer. Okay, yate duta particle log na lage, thousands and thousands of particles actually combine to give one particle of lyophobic colloids. Okay, they are towards the higher end of the size in terms of size. That's why they are visible. Otherwise, they cannot be visible, even if they are colloids. Okay, next. Visibility হৈ গল stability মানে কি existence থাকিব নে না থাকে যেনেকে আছে তেনেকে থাকিব নে না থাকে এটোৰ কাৰণে কি ডিপেন্ড কৰে the most important dependency is whether they are liking each other or not. Two person can stay together only when there is some kind of liking, right? If they do not like each other, how it is possible that they will stay together? There should be some reason. Okay, so like that, stability, these are very stable. It has to be. Why? Because it was loving, philic. Okay, these are very stable. Eto bahut stable hoy. Okay, and definitely you can understand what will happen in the case of lyophobic. These are unstable and requires traces of stabilizers. Ki hoy? Suppose there is a husband and a wife. Daily kajia kore, daily. So teneka ghorot ki hoy? Shanti nathake. But in that case, they will break down ultimately. But in that case, what can happen is, suppose they have very good friends or family members who make them understand that, see, the quarrel that you're doing is not good. Better you stay together happily. So they are known as stabilizers. Fine. So these are unstable and require traces of stabilizers. So when something is unstable, still they are together. That means there is some people who are stabilized. So similarly, in the world of chemicals also, the same thing takes place. These are unstable and requires traces of stabilizers. Trace small quantity. Fine. Action of electrolytes. Eta moi electrolytes fully kole tomaloke duta bostu mani loba that electrolytes has two parts. One is the cation, one is the anion. I'm just giving an example of sodium and chlorine because they are electrolyte definitely, and they have a cation part and an anion part. Fine. So very large quantity of electrolyte. This is in case of lyophilic, philic or carne. Very large quantity of electrolytes are required to cause coagulation. Okay, very large quantity of electrolytes are required to cause coagulation. Coagulation mane ki hoy? The best example of coagulation is, suppose you take a glass of milk. You take a glass of milk, squeeze lemon squeeze koi dia. Ki hobo ultimately? Lemon is also an electrolyte, weak electrolyte hodeo. This is also an electrolyte. The lemon juice is an electrolyte, correct? When you squeeze the lemon in the milk, definitely something is going to happen, which is like coagulation. That is, all the fats. Suppose this is a drop of lime juice or lemon juice. Okay, this is a drop of lemon juice. Lemon juice or eta drop yate jama hol. Lemon juice or charge thakibo, either positive, negative. It will have a charge, correct? It will have a charge around it. Lemon juice has charge. That's why it's a electrolyte. Nah? So what will happen is all the fats will accumulate around the one particle of this juice, and therefore eta particle jonto separate hoy ghuri asile etu log lagi dhoribo mane good khabo. Okay, as a result they become heavier as a whole. ठीक है, एक गोटे एटा milk particles की कोइले log laga start kore dise. Okay, they have started to just combine around the one lemon juice drop, okay, or one molecule of the lemon juice. So as a result they have become heavier when they started to combine, and they will settle down. ভারী হৈ গলে কি হ'ব? তলত পৰিব। নরমালি আমি কি কৰো, কেতিয়াবা আমাৰ ঘৰৰ ইয়াতে মানে যোনটো আমাৰ পানী আহে, আইৰন তো বহুত বেছি, পানীৰ আইৰন কোয়ান্টিটি বহুত বেছি। আইৰন পানী গাত ঢালিলে একো নহয় বাৰু, but sulit dhalile suli khoribo, like it will fall down, your hairs will definitely fall. So in that case, what is the best thing to do is use of alum, fitkari. Okay, fitkari tumaloke sobe, I think you all know about it. If you do not know, you just search. It is commonly known as an alum. It's a double salt. So এইটো ফিটকাৰি লৈ কি হয়, পানীত ৰাখি দিলে এই ফিটকাৰিৰ ওপৰত এনেকা ফিটকাৰি এটা ৰাখি দিলে, suppose this ফিটকাৰি is there, so little bit some small particles of the fitkari comes in water, and all the iron particles, they start accumulating they start being absorbed over the fitkari. ফিটকাৰিৰ ওপৰত গোটেই কেইটা আইৰন পাৰ্টিকলছ কি হ'ব, এডজৰ্পশ্যন হ'ব। কালি পঢ়িলো এডজৰ্পশ্যন মানে কি, এডজৰ্পশ্যন ঠিক আছে। এডজৰ্পশ্যন হোৱাৰ লগে লগে কি হ'ব, বস্তুটো গধুৰ হ'ব ন, হেভি হ'ব। তেতিয়া পানীটো ৰাখি দিলে কি হ'ব, এইটো তলত সেটেল হৈ যাব, ইট উইল ফল ডাউন বিকজ অফ হেভিনেছ, গ্ৰেভিটি। Under the fall of gravity, it will settle at the bottom of the tank or bottom of the vessel. Fine. This is known as coagulation. So coagulation কৰাৰ কাৰণে অকমান হলেও ইলেক্ট্ৰোলাইট লাগে। But coagulation হৈ গলে বস্তুটো কি হল, coagulation হোৱাৰ লগে লগে এই particular colloid টো শেষ হৈ যায়, ধ্বংস হৈ যায়, like this colloid is over. Now the milk will not stay as milk. Milkৰ ওপৰত যদি লেমন যদি squeeze কৰি দিয়া, তুমি চাবা, নিজেই চাবা কি হ'ব, it will not stay as milk. You cannot make anything out of that. Okay, that milk is completely gone, finished. Once you have added the electrolyte, means it is over. So see, in that case, so there again we can talk about husband and wife only in this case. So if the couple is very much like loving, they are very stable, then even if there is a lot of electrolyte coming to destroy it, then it will still survive under some conditions, but a very large quantity of electrolytes are required to cause coagulation. Coagulation means assimilation of all the particles, and they fall down under gravity. That's the end of the colloid, right? But in this case, it is easily coagulated. Junto lyophobic hoy. Phobic mane they don't like each other. For them, some small reasons are enough to be separated or to destroy their family. Easily coagulated by addition of little amount of electrolyte. Okman electrolyte le yes. Fine. Agor to asile, a lot of very large quantity of electrolyte is required for coagulation, and in this case easily coagulated by the addition of little amount of electrolyte. Okay, I hope this is understandable. If you have any confusions regarding it, you can ask. Next category. Okay, see, once precipitated মানে কি, তলত settle হৈ যোৱা। Precipitation means গধুৰ হৈ তলত জমা হৈ যোৱা। Okay, it falls down, right? This liquid, this will fall down. This falling down process is known as precipitation. Okay, precipitation means it is insoluble in water anymore, and it will settle down because it has nowhere to go. It will just fall down to the ground. Okay, in case of lyophilic, because they like so much each other, even there is problems, even their family is destroyed. Once precipitated, can reform into colloids simply by shaking. Simply by shaking, বা stirring. Common stir korle akko eto colloids bani jay. Okay, you have added the lemon. Okay, in the milk has become like curd, it has fallen down in the bottom. Again you shake it well, again it will become milk. If it does not happen, but eneka hoy in case of lyophilic. Okay, once precipitated, can reform into colloids simply by shaking or stirring. ষ্টাইৰিং মানে জাষ্ট পানীত চামুচটো ঘূৰাই দিয়া, সেইটোৱে আকৌ তোমাৰ প্ৰেচিপিটেটটো আকৌ তোমাক কলয়েডছ বনাই দিব। So there is every chance that they will reform. Even if there is quarrel, there is every chance that they will stay together. In case of lyophobic, now it has become easier to guess what is going to happen. Once precipitated, ekbar jodi precipitation hoy gol, once precipitated, can't be reformed into colloids. Finished. Their game is over. Okay, because they hate each other, that's all. They have no interest to form the colloid pack again. Fine. Okay, next, charge on particles. Key particle, solute particle. Solute particle or upor ketiaba charge thake. Okay, and that is helpful in building the colloids. That is helpful in building the colloids. I'll tell you how. Okay, that is helpful in building the colloids. They don't carry any charge. First of all, in case of lyophilic colloids, they do not carry any charge. Okay, and particles in case of lyophobic colloids, they have charge. Charge thakile ki hoy? Suppose they have charge, no? Suppose these are colloids. I am taking a vessel. Inside the vessel, there is a electrode which is negatively charged. Negatively charged means it is cathode, and positively charged has to be anode. Positively charged. Okay, fine. So colloids or ketiaba charge thake. It has charge, maybe all around the colloids there is some charge. Okay, so definitely this colloid, a colloid or charge ki kene gom pai, you will see that the colloid will accumulate around the cathode. Okay, this colloids will accumulate around the cathode. So if it accumulates around the cathode, I can say that it was positively charged because cathode is our negatively charged rod. And if this goes here, then I can say that this was negatively charged. Jodi ki eta colloid thake tar negatively charged scatter hoye ase all around, it will definitely go towards the positive part, that is the anode. Anode jodi anode around anode, if it accumulates, then I can understand that it was a negative charge because our anode is positive. Fine. Okay, so can I compare charge as an nine? They will start moving in a certain direction. Either they will move towards the cathode or they will move towards the anode. It only depends upon, like suppose it is moving towards the cathode, then definitely I can understand that what is its charge. Okay, particles move in specific direction, either cathode or anode, depending on their charge. So tar charge to ke heter upor depend kore, whether it is positive, negative, whatever. Fine. So that is known as charge. Fine, done. Next, hydration. Next topic is hydration. I mean charge loke chalo, charge on particles loke chalo. Next topic is hydration. HYDRATION, hydration. Whether it is hydrated, whether it is not hydrated. Okay, so one of the reason of stability is they are heavily hydrated. Jiman molecule stable boli koa hoy, suppose eta bostu panit koi bahut stable hoy ase, stable hoar mane tar bahut hydration hoise, because when something becomes hydrated, hydration energy is released and that makes the compound more stable. Because lyophobic is stable, sorry, lyophilic hoy stable hoar eta reason hol hydration, lot of hydration hole ki hoy, it releases hydration enthalpy, which is negatively charged. It is releasing that, and because of this negative charge, negative charge bolo, Negative energy means exothermic. Because this energy is going out, it is making the compound highly stable. Fine. So this is all, that's all. Fine. Okay. Next is lyophobic. Lyophobic. So in case of lyophobic, what is the thing? Not appreciably hydrated. They are not hydrated to a higher extent. Basically hydrated no, I can even stable or no, unstable attack. Easily identifiable, you can identify. Just remember this points. Few points also, if you can remember, you can write it, you'll get marks. Okay. Last is Tyndall effect. If possible, I'll show you Tyndall effect. Just 1 minute. You hold on. But when we take this, okay. Okay, 1 second. I kept it mute. Okay, I'll just re-explain. So this liquid is there, and if I just put the light in it, then this liquid starts to glow. Fine. This liquid is exactly glowing. Why it is glowing? This is the Tyndall effect. Okay. If I remove this and put a different liquid around it, okay. If I put a different liquid around it, so you can see that there is no glowing effect. Glowing effect nahi. What is the possible reason around it? because this liquid is unable to show you Tyndall effect, whereas the other liquid, it glows very well. Okay, this glows very well. It glows so that it shows you Tyndall effect. ঠিক আছে? আচ্ছা, Tyndall effect to বুঝে এটা আমি থিওরিটিক্যালি হে গম পালো কেনেকে হয়, let us understand. Okay, fine. So why this Tyndall effect takes place? Now it is said that lyophilic colloids, they don't show Tyndall effect. Why? Probably because of their very small size. Very small size. What happens in case of other liquids like the lyophobic? They show Tyndall effect. Why they show Tyndall effect? I'll just explain a little bit. Fine. What is, by the way, Tyndall effect? Tyndall effect is nothing but the scattering of light by the solute particles or the dispersed phase particles. Okay, like there is the particle is there. Okay, this light is falling on the particle. This particle is able to scatter the light all around. This is a dispersed phase particle. So this dispersed phase particle, when a source of light falls on it, it is able to scatter the light all around. So that's why we see that the liquid actually glows. Okay, this is nothing but our Tyndall effect. Fine. So what is our Tyndall effect? I hope you have understood. When the particle sizes are, who can scatter the light? First of all, who can scatter the light? Who can? Why the sky appears blue? Anybody? Yes. Who can scatter the light? Why the sky appears blue? Same thing. The air particles, the dimensions or the size, diameter of the air particles, are almost in the range of the, almost in the range मतलब लगभग same होता है, almost in the range of the wavelength of light. ठीक है? The sky is blue because the blue color is scattered by the air particles. ठीक है? Sea water is blue, same reason. Green, it is sometimes different colors, but normally we know that it should be blue ideally. So it is just reflecting the sky. The colors that is reflected, exactly, the word reflected is to be used. This dispersed phase reflects the light. Whatever light it reflects, that color you will see. Okay, there is no restriction. It is blue, red, green, yellow, orange, whatever. Violet. In fact, you see violet. The only color you can see the sky is violet sometimes. The sky is pink or red sometimes. The sky is blue sometimes. The sky is orange sometimes. Fine. There is always a tendency of yellowish, if not yellow. Okay. The only color I have not seen sky is green. Okay. Anyways, so the understanding is clear how it takes place, what it is. What is the Tyndall effect? Tyndall effect is nothing but the scattering of light by the particles of the dispersed phase. Tyndall effect. It is the scattering of light by the particles of the, it is a scattering of the light by the particles of the dispersed phase. Okay. And who will scatter? If the wavelength of the light and the particles diameter is of the same range or the same type, similar, is very similar, then only they can do it, otherwise not. The size of the dispersed phase particle must be very close to the size of the wavelength. Size of the wavelength. Fine. ठीक है. ठीक है. All right. So next topic is multi-molecular colloids and macromolecular colloids. There are two types of colloids. There is three types, but in your course only there is two types. One is associated colloids is also there, but let us stick to the topic. There is multimolecular colloids and macromolecular colloids. Okay, there is two types of colloids. So we'll just write one by one. Multimolecular. From the name only you can understand that lot of molecules are involved in making the colloid. So there is aggregation. Are you getting the point? Aggregation. Because নহলে multimolecular কেনেকে হ'ব? Colloid or এটা colloid or lump এটা আহিছে, but that is comprising of lot of molecules. Okay. So aggregation, it is nothing but the aggregation. Aggregation means summation, combination. Aggregation of small atoms of molecules, small atoms of molecules, aggregation of small atoms of molecules. Okay. What is macromolecular colloids? It is the combination of, it is not combination, it is large molecules in itself. Macro means large. তুমি লোকে photography চাবা, macro photography. সৰু এটা বস্তু ডাঙৰকে দেখায়, that is macro photography, right? So macro means large, consists of large molecules. Both are colloids. Large molecules means they are very close to 1000 nanometer. Aggregation means they have combined to form, right? In case of multimolecular colloids, এই like aggregation to হয় কেনেকে, মানে এটা particle আহিলে আৰু এটা particle লগত লগ লাগিব, জোড়া খাব, like they will just attach to itself. So how this attachment takes place? There should be some binding energy, right? There should be some force of attraction. So what is the force of attraction acting between them is van der Waals forces. So it's a weak force. It is known as the van der Waals forces. They are actually holding on the molecules together. ठीक है, held holds the atoms or molecules together, atoms or molecules together. Fine. Next, number 2. In case of macromolecular colloids, there is no question of binding force because a molecule in itself is qualifying as a colloid. Okay. So here molecules are flexible. Molecules are flexible and can take any shape. Jikono shape lobo pare. Okay. Molecules are flexible and can take any shape. So this is describing a macromolecular colloids. So another point just monotonic level, 2 points to monotonic, that point only you write. Okay. Fine. So here, because they are small molecules combining to form colloids, so the molecular mass is not very high. Okay. Low molecular mass. And here it will be high molecular mass. High molecular mass. Fine. Low molecular mass and high molecular mass. In case of macromolecules, because they are big size molecules, they have to be a little bit heavier. Okay. So aggregation कार क्षेत्र देखेছিলো lyophobic. In aggregation was actually the characteristics of lyophobic. Fine. So number 4th point is lyophobic character. Lyophobic character. And number 4 here is lyophilic character. Fine. Lyophobic character and lyophilic character. So that's all. These are the basic understanding of multimolecular colloids and macromolecular colloids. Fine. Okay. So we are moving on towards the climax of this chapter, or there's only 2 more topics left. So we'll just go a little bit slow. Let us understand these texts. These are important. And that is the properties of colloids. Okay. You can match with the syllabus. We are going accordingly. Properties of colloids. Okay. Properties of colloids. So here something very important is going to come. Normally it comes in the exam, Brownian movement. So we'll go to that one by one. Some physical properties. Already physical properties আমি ইমান খিনি দেখিলো, তার ভিতৰৰ পৰা কেইটামান physical property আমি লিখি দিম. Some physical properties are, they are heterogeneous in character. Correct? Heterogeneous in character. Heterogeneous. Okay. B is they are of stable nature. Okay. Provided they are lyophilic colloids, they are more stable. And C, they can be filtered, they can be separated. It is not like true solution where it cannot be separated. Salt or water jodi mix kore dia tabi se eto separate koribo nwari. Normally you cannot do that. Okay. If there are special methods, I also may know that. Okay. So it is filterability. You can separate them. Okay. So heterogeneous, stable nature, and filterability. Fine. So there is physical properties. What are the physical properties? Heterogeneous nature, stable nature, and filterability. So this is one of the best property. Okay. Next. Colligative properties. Okay. What are colligative properties? Colligative properties. Okay. So what are colligative properties? You already know. The properties which depend upon the number of particles. Okay. Colligative properties already तुम्हालोके पढ़ी सा आगोते solutions और क्षेत्र. The properties which depend upon the number of particles, right? Okay. So these are the properties which depends upon the number of particles. मान लो क्या होता है for is relative lowering of vapor pressure, then elevation of boiling point, freezing point, depression, osmotic pressure. ठीक है. In case of true solution, these properties were valid, but in case of colloids, okay, in case of colloids, only you will find some relative accuracy with osmotic pressure. ठीक है. So only osmotic pressure is related. Only osmotic pressure is related. Fine. So that is the colligative property. Osmotic pressure is related. Okay. So the osmotic pressure of colligative colloids are only related to the osmotic pressure aspect. Other like elevation of boiling point, freezing point, depression, ये black और kind. ठीक है. Okay, done. Now, one important property is Brownian movement. ये तो आया है परीक्षा. Brownian movement. Brownian movement तो है कि है तो मैं discuss करी है. ठीक है. Brownian movement. Suppose there are particles. ठीक है. There are particles. These particles are coming and bombarding. ठीक है. माने कि এটা particle আৰু এটা particle খুন্দা খায়. They are just, so the particles are particle. This red is some kind of particle. It is coming. It is like it is hitting somewhere. It is going somewhere. So this molecules, যদি এটা কিবা এটা molecule হয়, ই কি হ'ব? It will have always a zigzag kind of a motion. ठीक है. The colloids particles has a zigzag motion in its liquid. ठीक है. Basically the smaller particles, because কি হয়, in case of colloids there is two kinds of particles. One is the bigger particles. Colloidৰ range to কি 1 to 1000. So 1000 to hold ডাঙৰ particle আৰু 1 in the smaller particles suppose. So এই colloid যেতিয়া movement কৰে তেতিয়া এই ডাঙৰ ডাঙৰ particle পৰা খুন্দা খায়. Okay, they are getting bombarded. As a result, because they cannot make this bigger particle move, but because they get bombarded, they are coming back in a zigzag fashion. Okay, they're coming in a zigzag fashion. Fine, they're coming in a zigzag fashion. So these particles are getting bombarded And therefore, these smaller particles, which are also basically colloids, these are bigger particle colloids, like 1000 nanometer. They are closer to 1000 nanometer, and this is closer to 1 nanometer. The smaller particles are getting bombarded, and therefore their movement always remains in a zigzag fashion. So this is our Brownian movement. Okay. So what is this Brownian movement? First of all, it depends upon the size of the particles, right? So I'll write few points. Brownian movement, okay, depends on size of the particles. Number two, depends on size of the particles. Okay. Next is number two is viscosity of the solution. Viscosity of the solution. Okay. It depends on the size of the particle and viscosity of the solution. Okay. Depends on, what is the meaning of viscosity? Viscosity means, suppose there is two layer of liquid. Viscosity sidha moi koi aso. You take oil. Oil to dhorile keneka lage, okoman chipchipa lage, no? There is like chipchipa. This chipchipa means viscosity. Grease lole aru besi chipchipa hoy, like they are like more like they have more friction between the layers of the liquid. So you take water, what is the level of viscosity? Very less. Pani jodi pani okoman hatot loi jodi eneka kora, so it will give you very less resistance, like nothing is there almost. But if you take oil, lot of viscosity. If you take gum, more viscosity. If you take gel, very high amount of viscosity is there. Viscosity means basically মানে লিকুইড টু বা কলয়েডৰ নিজৰ মাজত কেনেকুৱা ফ্ৰিকশন হৈ আছে, যিমান ভিস্কোসিটি বাঢ়িব ইমান মুভমেন্টটো কমিব, ঠিক আছে? Because viscosity কি হয়, suppose there is two layers, the one layer is trying to move in this direction, the other layer is trying to move in this direction, they will oppose each other in their movement. More the viscosity, the opposition will be higher. It is the friction between the layers. This is known as friction between layers of liquids. This is known as a viscosity. Depends on the size of the particles, depends on the viscosity of the solution. Okay. Depends on the size of the particle, depends on viscosity of the solution. These are the 2 points. Okay. So যদি সাইজটো সৰু হয় আৰু যদি ভিস্কোসিটিটো কমি যায়, তেতিয়া কি হ'ব? Brownian movement, this zigzag motion will increase. Okay. So sizeৰ লগত Brownian movement মানে this zigzag motion. Okay. This sizeৰ লগত এটো যিমান সৰু ইমান বেছি inversely related. Brownian movement, BM মানে Brownian movement, size is inversely related. And viscosity লগত inversely related, যিমান কম হ'ব viscosity ইমান বেছি Brownian movement হ'ব. Fine. Smaller the size and lesser the viscosity, faster is the movement, faster is the motion of the particles. Okay. So Brownian movement depends on the size of the particles, depends on the viscosity of the solution. It is the zigzag movement. It is the zigzag movement of smaller particles, smaller colloidal particles, due to the bombardment, of the heavy particles. The bombardment of the heavy particles. Okay. So this is the main important point. What is a Brownian movement? It is mostly asked. So you can write on your own. Okay. Try to understand, write it. Okay, fine. I hopefully have completed most of the part. Just one topic is left. Okay. And that is electrophoresis and coagulation. Last of. Okay. Just two topics are left. Electrophoresis. Simple topic. What is a electrophoresis? Okay. So already we have discussed. So suppose you have taken a colloid in a vessel, and then there are two electrodes. One is the positive electrode, one is the negative electrode. So there is the positive electrode, okay, and then there is the negative electrode, okay. Now, when you connect it over a battery, battery दे दिला, positive negative battery दे दिला, okay. So in this liquid, what happens? If the colloid is positively charged, definitely it will move towards the negative, which is the cathode. Definitely cathode to hoda right or thake, my agar bar left or this, it should be always on the right. Okay. So this, if it is moving towards under the influence of this electric field to keneke producer because of the presence of this battery. Okay. It is the phenomenon. It is the phenomenon of movement of colloidal particles under the influence of applied electric field. Under the influence of the applied electric field. So such a case is known as electrophoresis. So this is what happens. Okay. So just by where it is going, just by the movement of the direction, you can find out whether it's a positive sol or a negative sol. Okay. So we can just give an example, because it is accumulating over the negatively charged cathode, so it's a positive colloid. Okay. Since the particles of colloids is accumulating over, since the particles of colloid is accumulating over the negative electrode, the charge on the particle, negative electrode means cathode, the charge on the particle is positive. Fine, the charge on the particle is positive. I'm just going a little bit higher in time. Just the last topic is left. Okay, time lego, past me. Fine, so this is electrophoresis. Okay, so last topic, coagulation. Already pohiso, coagulation mani ki, coagulation means combining and then settling at the bottom. Okay, so settling at the bottom is known as precipitation. So just write the definition: the phenomenon of precipitation of colloids, of colloidal solution by addition of electrolyte, right? By addition of excess amount of electrolyte is called coagulation. Okay, fine, that's it. Your surface chemistry is over. Okay, so whatever I have taught, just go through and you will do fine. There is no issues with this chapter. Try to do we'll definitely do some numericals, not numericals. We'll definitely do some important questions. There is no numerical in this chapter. There are many important chapters. Most of them has been deleted. So whatever it is there, just do this much. You will do fine. Okay. So thank you, everyone. I'll upload the video. There have been some problems with the videos. I'll just re-upload them so that all of them are in serial order. So thank you.